Hello, in this video I'm going to talk about test-driven development, and I'm going to open up the model which I'm going to start talking about. Okay, so in here I've got a few examples. I'm going to work through each one. So the first one is kind of like the classic case that people will code and then try and test it, and we'll see the problems with this code in here and why it makes test-driven development really difficult to do. So if I open up the tests as well, so this is the example tests, don't worry about the other ones just for now. So this code in here, what it does is it instantiates a new database talker. This is just a random object that I've created. It doesn't actually talk to any database, but I mean in a real setting this would be talking to the database, fetching one row with a certain ID. It itself is an object, and obviously it has methods on it, and you can do various things. So I've brought in some of the ideas that usually are available in SQL, so you can wrap things in transactions, and this is how people would probably go about testing this bit of code. Obviously the caveats is that you're testing the database itself, and you're also testing this library. This might be Zen framework, this might be something which you know that's pretty safe and you don't really want to test that, you want to test your own code. So in here we're actually fetching one and we're just concatenating the first name, last name. The SQL structure is probably going to remain the same, so it's not really an issue. So in here we'll begin a transaction, we'll insert a row into that database, we'll then get that row out, and we'll see if the string matches. We'll also roll back afterwards, because obviously you don't want this random data in your database, and you probably end up with loads of Robert Does in your database if you kept running your tests all the time, which you probably should be doing. The other issue is if this code here returns or throws an exception at any point. If, for example, if the first name is blank, you might choose to throw an exception. In this code, this is pretty bad because when you run this, it won't ever hit the rollback, and that means that you're going to leave test data in your database. Obviously, you can reset your database, but this is not ideal, definitely. So there are many ways that we can improve this. I'm going to talk about 3 different ways, 2 of which are quite common, and the third one is some ideas of my own. And you can obviously see all of the problems that I see with all of the different ways of doing it. Okay, so this example shouldn't do it this way. Don't do it this way. This is horrible. Okay, so I'm going to talk about dependency injection first. So commonly you'll have, in most dependency injection frameworks, you'll have some sort of class that acts as your registering tool. So you register an object and then you can pull it out of the injection framework whenever you need it. So in this example we've got database person, which is the same class that we used in the previous example, and we'll pull out one row, same as before, pretty much the same code, except now it's wrapped in this call. Now the problem I don't like with dependency injection is that the return type of this is now not deterministic, and if you're working in an IDE like I like to, this becomes an issue because then you don't get some nice code completion. So if I remove this line, which I put in to kind of get around this as a hack, I'm telling PHP Storm that this has a type of database person, but it potentially could be null, could be anything. Anyone could have put in any random object to database person. So if I remove that line and then try and call a method on Talker, I'm not going to get any code completion, which is really helpful in speeding up your code writing, and I think it's a really good tool. And when you use dependency injection, this just becomes a pain because you have to keep helping the IDE along, which takes time. You may as well have not bothered putting that in and just spent the time writing out what the method actually is. So Maybe in some models you might be making a lot of calls to talker, but personally I think that this is a really bad way of going about it just for this purpose. It also does mean that you need to create also a mock object that you're going to register with the dependency injection framework, and that has its own, uh, you have to write some more code to generate that mock object, and it probably extends the original object that you wanted to mock, or you're using a framework like Mockery. Either way, you're going to have to write some more code there. So this is not ideal either, I don't think. And obviously, this doesn't talk to the database, so you're not going to have to worry about anything going in the database. Okay, so the last two examples. Let's close this up. So this model method, we actually use this object person as a way of dealing with this. So we don't actually return the full name, we return the object. So this method name is a bit misleading, sorry about that. But anyway, we create a new database talker, we fetch one row from it, and then we populate this object. And I guess you could write this to return the object person. Some frameworks allow this and allow you to extend the objects. Yeah, this is perfectly fine. You can wrap up your pure code in the object itself. So in object person, got get full name, and this isn't reliant on the database. I mean, you can generate a new object person from data that's not even in the database, and you can test it and figure out if this method is actually going to do what it's supposed to do. So in the example test here, we've got the new object person. We assign the values to the public properties, and then we just test that the get full name method actually returns the correct result. Obviously, this is pretty nice. The only downside I can see is that you have to write some more code. There's a whole new class here, object person, which you would have to write this if you've got a large project with lots of model methods in it. You're going to have to be creating a lot of objects to represent all of the different data types that you've got, and Java people probably like doing that quite a lot, but if you're writing PHP code, it's probably likely that you want to keep things quite compact as possible. So I'm going to talk to you about this fourth example, which takes some ideas from Haskell, but is actually really simple to get your head around. I've called it monad. If you are a Haskeller, you probably look at this and go, that's not a monad, but I'm going to call it a monad because it kind of has similar properties to the way that monads work and how they separate pure code from code that causes side effects like talking to a database. So in this example, I have got this object, this new one, this monad wrapper, but you can use that for all your models. So this is write once and use many times. So not like the case with person objects, where you're probably going to have to create loads of different objects to relate to different data structures. In this example, we only have to create one wrapper, maybe a couple of wrappers. It depends on what the unsafe the side effect code is actually doing. It might be that you have to write different wrappers because the ordering makes a difference on when the side effect code actually runs and what you're pumping into it, whether it needs to run first or after your pure code, and that's completely design issue. So you just have to figure it out. So let me show you the monad wrapper code. So all this does is very simple. It's got two properties, side effects and pure, and they're both closures. Takes in the side effect closure, takes in the pure closure. Yeah, even again, this could potentially not be a closure. If you're working with Zen framework, you might have select object, ZenDB select object, you could pass that in here and then write in this get method the code to just do the query and fetch all or whatever you want to do there, and you could make this look quite nice because you could have it taking the select object and then you don't actually have to wrap it all up in a closure. And you, if you're in PHP 5.3, that might be quite nice. 5.4, it's not really so much of an issue because closures work a little bit nicer. So what it actually does in this example is it runs the side effect code, which is in your closure. I have to do this binding, otherwise it calls side effects method, which doesn't exist. And also the pure binding is not actually a method, so I have to bind it to a local variable first. I take the value and I put it into the second closure, which will be your pure code. And the way that that works is that it's literally first closure, calls the database, fetches one in the ID, and we're using that ID in the closure, so we have to bind it using use ID. And then in the second closure, we take the result, which is the return value from here, and then that comes in as person to the second closure, and then you use that to concatenate the first and last name. And as you can see, all the code that is required to do this is all in the model. So if you read the model, you can see exactly what's going on. And if you order your arguments to monad wrapper accordingly, you can actually make it be in perfect order, so you can read it as if it's normal imperative code. So if I look at this one again, I mean, it has the same properties in that you've got the separation of the side effects and the pure code, so obviously it's quite nice, and you don't have to create all of these objects. So if you want to get the value out of this, because obviously this is going to return a monad wrapper, you also need to call get on that monad wrapper, and that will actually run the code. So actually calling get full name monad won't actually do anything. You could potentially throw that up to the view or whatever. It all matters how your framework's set up, but yeah, you can defer this call until you actually need it as well, which is quite a nice property. So this get binding, this will return the closure which has the side effects in it. Sorry, correction. It will return the code which is pure, which is the pure code that we've got here, which is person, and it concatenates the two together. So very similar, it's the code that would be in the object person. So in the test, we've got creating a new object, model example 1. We then call get full name monad, and the argument doesn't matter, so I've just passed in 0. We get back a monad type, and then we get the binding, so that'll get the closure out of there, which has got the pure code in. And then we call that closure with some fake data, and it's very similar to our mock example in that we're passing in data that we want to test on, and we want to ensure that we're not talking to the database in any way, so we don't actually call get on this monad here, so it's not actually talking to the database. And with this you can create very testable code that isn't reliant on rollback of SQL statements, and also you get this nice property which is that all the code is all in one place. For some things this might be really relevant. For others, probably want to create objects. If you've got lots of code, probably don't want to be creating hundreds of lines of code in your models. But for something like this, if you want to test that concatenation works, I know it's a naive example, but I mean in a larger situation you might be concatenating 50 different items, and you want to test that there is no comma in there or something. And I mean, if someone comes along one day and decides I'm gonna put something at the end, it will fail the tests, and you will see that actually your program's not operating as the original programmer intended. So these are the 4 different ways that I can see doing test-driven development with models can work. I mean, Of the four, I don't think that you should do anything like the first example. I think this is a really bad way of testing. It's also very slow because you've got to hit the database every time, and obviously that has its overheads. And if you've got 50,000 tests in your project, then you're gonna be waiting a while for Jenkins to run and finish and give you a result, which is obviously not a good thing. And it's also, as I said before, it's not really relevant to test Zen framework is working. I mean, Zen have done their job of producing very stable code, and you don't really want to be testing that their code works, because most likely it will. The only drawback that this has, obviously, is it won't test broken SQL statements. Um, I mean, in this example, the SQL statement is very simple. It's just passing in a where for the ID. So obviously that's not a problem. But if you had a more complicated SQL statement, then perhaps I would suggest that you need to create test data. But you need to be very careful that if you throw an exception in your model, or there's a possibility an exception can be thrown, that you catch that um, in your test. You catch it so that you can do this rollback. Otherwise, you're going to end up with a very full database. And I've seen situations where Jenkins can actually get full, run out of disk space the instance, and this isn't a good thing, really. I mean, you don't want to have to be maintaining your Jenkins, resetting the database every time, because obviously resetting the database is can be extremely slow as well. So I think it's beneficial if you follow one of these three different patterns. I think the dependency injection can work for people that don't like IDEs, but really you need to be using an IDE. The objects one is very verbose, and obviously the monadic one has a very nice way of kind of keeping things together, but it's only really good for short amounts of logic. I mean, if you've got anything substantial, then I would suggest that you need to go for the object route. But there you go. That's my talk on test-driven development. Thank you for your time. I'm trying to get out of this now.